There's a computer Nvidia built specifically for AI. It's got the word right there in the product line. It costs around $4,000, and for the exact thing you'd buy it to do, run a big model at home, a Mac Studio beats it. A Mac. A computer Apple sells to video editors that happens to be one of the best local AI machines on Earth entirely by accident. That should feel wrong. Nvidia is the AI company. They print the chips the whole industry runs on. Their stock ate the decade. And yet the moment you try to run a large model on your own desk instead of renting one in the cloud, the obvious pick and the right pick stop being the same thing. So which one do you actually buy? The graphics card, the little Nvidia box, or the Mac? Stick around, because the answer isn't a brand. It's a single number most spec sheets bury. And once you know which number to read, this entire fight collapses into one clean rule. Here's the picture we're going to live in. Running a language model is like a librarian answering a question out of a giant reference library. And here's the part that breaks everyone's intuition. To produce just one word of the answer, the librarian has to consult every single book in the library once. Then to produce the next word, they do the whole thing again. Every word, the entire library, cover to cover. That's not a metaphor for how it feels. That's mechanically what generating a token is. The machine reads through the model's entire memory, every time. So 3 things about that library decide everything, and they map exactly onto 3 numbers on a spec sheet. First, how big is the room the librarian works in? That's memory capacity. VRAM on a graphics card, unified memory on a Mac. If the whole library fits in the room, great. If it doesn't, the librarian has to sprint to an off-site warehouse mid-sentence to grab the books that didn't fit. That sprint is your model spilling out of fast memory into slow system RAM, and it is catastrophic. 10 times slower, easy. So rule 0. The library has to fit in the room. If it doesn't, nothing else matters. Second, how fast can the librarian physically pull and reshelve every book? That's memory bandwidth measured in gigabytes per second. Since they touch the whole library for every word, this number basically is your speed. Words per second lives here. Remember that. Bandwidth is the hidden boss of this whole video. Third, how fast the librarian reads once a book's already in hand. That's compute. Raw processing power, the thing Nvidia is legendary for. And here's the twist that catches everyone. For chatting with a model one response at a time, compute is usually not the bottleneck. The librarian's reading speed doesn't matter if they spend all day walking to the shelves. Bandwidth is the walk. Compute is the reading. Most of the day is walking. Now the 2 philosophies make sense, because Apple and Nvidia each picked a different corner and refused to compromise on it. Nvidia's classic play is the graphics card. Take the RTX 5090, around 32 gigabytes of the fastest memory money can buy, screaming along at roughly 1.8 terabytes per second. That is a librarian on rollerblades in a phone booth, blindingly fast on anything that fits, and the room is tiny. 32 gigs holds a small or mid-size model beautifully. Try to load a serious 70 billion parameter model and it doesn't fit. The librarian starts sprinting to the warehouse and your rollerblades don't save you. Speed, no space. Apple did the opposite. The Mac Studio's trick is unified memory. One big pool of RAM, the processor, and graphics share, and you can spec it absurdly high. The M3 Ultra goes up to 512 gigabytes. 512. You can load models on a Mac that physically cannot fit on any consumer Nvidia card. Full stop. Enormous room. The whole library fits with shelves to spare. But the librarian walks at a normal human pace. That bandwidth, around 800 gigs a second, is a fraction of the 5090s. Space, less speed. So there's your triangle. Capacity, bandwidth, compute. Pick your fights, because no consumer box maxes all 3. And that's the frame you need for the machine I opened with. Because Nvidia saw the gap. They watched people buy Macs to run big models, and they built an answer, the DGX Spark. A little desktop box, unified memory like Apple's, 128 gigabytes of it. Finally, an Nvidia machine with a big room. On paper, the Mac killer. And then the reviews landed, and here's the gut punch. That big Nvidia room has a librarian slower than Apple's. The Spark's memory bandwidth came in around 270 gigabytes per second. That's not a little under the Mac. It's roughly a third of it. Nvidia, the speed company, shipped a big memory box that generates tokens slower than the Mac Studio it was built to beat. It'll load the giant model, and then read it to you at a walk. That's why the $4,000 AI box loses to the Mac at the one job. Same room size idea, slower shoes. Now, Credit where it's due, because this is where the honesty has to kick in, and both sides have a real case. Nvidia is not actually losing. That Spark bandwidth number looks bad for chatting, but the box has real compute and it runs the full Nvidia software stack. CUDA, the thing every AI tool on Earth was written against first. If your job is training, or fine-tuning, or running many requests at once instead of one chat, compute and ecosystem start mattering more than raw chat speed, and Nvidia pulls back ahead. And a straight 5090 for any model that fits in 32 gigs will embarrass everything else in this video on speed. It's not slow, it's small. And Apple's win has an asterisk too. Yes, the Mac loads the huge model, but loads it and runs it pleasantly aren't the same sentence. Push toward the really big models and even 800 gigs a second starts to crawl. You'll watch words appear at reading pace, not thinking pace. The unified memory magic is real, but it's a capacity win, not a speed win. Don't let anyone sell it as both. And everyone here is selling. Nvidia needs you to believe local AI requires their hardware and their software moat. Apple is thrilled to be the accidental AI darling because it moves $5,000 machines to people who'd never have bought one to edit video. The benchmark accounts want the fight to stay a fight because it depends doesn't trend. I've got nothing on the table but a subscribe button, so let me just tell you what to actually buy. Start with one question, and it's the only one that matters first. How big is the model you want to run? Not your budget, the model. Figure out how many gigabytes it needs in memory, because that decides your whole tier before a single dollar does. If your models fit in 24 to 32 gigs, most of the genuinely useful local models do. Buy the Nvidia graphics card, a 5090 or last generation's 4090 if you want to spend less. Fastest answer for the money, best software support, done. Don't overthink it. If you specifically need to run the big models, the ones that laugh at 32 gigs, the Mac Studio with a lot of unified memory is the quiet best buy on the planet right now, and it sips power doing it. You're buying the room and accepting a librarian who walks. The little Nvidia box, the Spark, is the narrow pick. You want it if you're a developer who needs the real Nvidia software stack in a small package for building and testing more than you need the fastest possible chat. Know that going in, or you'll feel the bandwidth every day, and the move most people miss. You don't have to house the whole library. Run a small, fast model locally on a card you can afford for the private, everyday grind, and keep one cloud key around for the rare day you need a model too big for any desk. Rent the cathedral. Own the reading room. Back to that $4,000 AI box getting beaten by a Mac. It's not that Nvidia forgot how to build. It's that best AI hardware was never one thing. It's a room, a walking speed, and a reader. And no box on your desk wins all three. The best machine isn't the one with the brand. It's the one whose room fits your library, and whose librarian isn't stuck sprinting to a warehouse in the middle of every sentence. Read the bandwidth number. That's the whole game. See you in the next one.